Hey everybody, this is lesson 7.3, factoring trinomials with a lead term of x squared. You might also hear that this is called factoring trinomials with a lead coefficient of 1. Okay, so we kind of use these two phrases interchangeably. Excuse me. Okay, so to start off with, let's just do a real quick refresher on what we were working on last unit with polynomials. So when I have two polynomials and I need to multiply them, and if you remember, these are what type of polynomials? Binomials, because there are two terms. But anyways, when I multiply, I double distribute. And then I combine like terms to get my final answer. So when I'm looking at this, we want to see if we can notice anything, any patterns that we can pick up in the use of factoring, because as we talked about last week, factoring is basically the opposite or the reverse, the undoing of multiplication or double distribution. So what do we notice about the coefficient of the middle term with respect to the original numbers? So here our coefficient is 7. And what can I do with these these numbers up here? My original problem that would have gotten me 7. Well, the 3 plus 4 equals 7, right? So the middle coefficient is the sum of it's the sum of the original last two terms. And what do we notice about the constant with respect to the original? Well, the constant is 12. And so if I'm looking at my first original problem, how could I got 12? 3 times 4 equals 12. So the constant is the product of the original last two terms. Okay, so that's very important because we're going to use that knowledge to go in reverse. So when we're factoring with the lead coefficient or the lead term of x squared, this is our basic pattern. X squared plus bx plus c. And we have an example here where b would be 7 and c is 12. So we need to find the two numbers that multiply to get you c. So in this case, c equals 12. So let's start listing numbers that we can multiply to get to 12. 1 and 12, 2 and 6, 3 and 4. Anything else? Well, those are all the numbers. Okay, so we need two numbers that multiply to get us 12. And we need two numbers whose sum is b. So my sum here is 7. So which of these three of these sets could I add together to get 7? The last set, right? 3 plus 4 equals 7. So that means that if I wanted to write the factored version of my original problem, all I would need to do is write two sets of parentheses. We're going to put an x in both because my leading term is an x squared. And then I'm going to have plus 3 plus 4, and this would be my factored answer. And that's all there is to it. We just find more terms as we go along and more patterns.